the channel. In this video, we're going to talk about interior angle measures of polygons. Now, we do have a formula for this, and instead of me just going out and giving you the formula, we're going to talk about where it comes from and see if we can derive it ourselves. So let's look at four quadrilaterals we have here. Four polygons we have here. The first one is a quadrilateral, looks like a rectangle, right? So let's just see the number of sides that we have here. So we have 1, 2, 3, and 4 sides in this shape. The next one we have 1, 2, 3, 4, and 5. And the last polygon we have 1, 2, 3, 4, 5, and 6, okay? So for our first shape here, we could call this a quadrilateral because it has 4 sides. The shape in the middle we call a pentagon, and the shape on the right we call a hexagon. So when we're talking about the interior angles of a polygon, there is a formula for us to use. So where does this formula come from? Well, it comes from splitting these polygons into triangles. So how we do that is we take and we add in a line from vertex to vertex to change the polygon into any number of triangles that we see. So let's start first with our quadrilateral. So we take and let's draw a diagonal here so that we have now created 2 triangles. Now we can think about what are the measures, the angle measures of a triangle. What do they add up to? Well, they add up to 180 degrees, right? So I know that I have 1, 2, 3 angles right here, and that's 180 degrees. And I have 1, 2, 3 angles right here, and that's also 180 degrees. So now I know, okay, this shape here, the interior angles must add up to 360 degrees. Okay, so now let's do the same thing for the pentagon. Let's take and let's draw a line there. So now we have a triangle on the left, and let's take and let's draw another one right here. So now you see we have 1, 2, and we have 3 triangles. Each of those 3 triangles, their 3 angles are going to add up to 180 degrees. So we know we could take 180 times 3, and we get 540 degrees. Okay. And now the last one, let's draw some triangles here in the hexagon. So there's 1, and there's 2, and let's go right here. Okay, so now we have 1 triangle, we have 2 triangles, 3 triangles, and 4 triangles. And keep in mind, each of those triangles add up to 180 degrees, right? So we can take 180, we can multiply that by 4 to get our angle measure. So 180 times 4, and we get 720 degrees, okay? So now, let's look at the number of sides that these shapes had and what we multiplied 180 by to get the total or the sum of the interior angles. So our first shape was a quadrilateral, had 4 sides, right? So essentially, in order for us to get 360, we multiplied 180 times 2 because we had 2 triangles that we were able to create inside that polygon. In the pentagon, we multiplied 180 by 3, and in the hexagon, we multiplied 180 by 4. So if you notice the pattern here, we are multiplying 180 by 2 less than the number of sides that the polygon has. So if we look down here, it says the sum of the measures of the interior angles of a convex n-gon is, and we can write that as n minus 2 times 180, okay? So however many sides the shape has, subtract 2, multiply that number by 180, and that's what the sum of the interior angles is going to be, okay? So let's look at some examples. Example 1 just says find the sum of the measures of the interior angles. So let's start off by figuring out how many sides we have. Okay, so we got 1, 2, 3, 4, 5, 6, 7, and 8, right? So we'll call this an octagon. So we're gonna say n minus 2 times 180. So now we know we have 8 sides, so 8 minus 2 times 180. Well, 8 minus 2 is 6, and we can do 6 times 180, and we get 1,080 degrees. Okay, so the sum of the measures of the octagon is 1,080 degrees. All right, example 2 says the sum of the measures of the interior angles of a convex polygon is 1,800 degrees, or 1,800 degrees. Classify the polygon by the number of sides. So here they give us the sum first, and now we want to figure out how many sides we have. So let's think about our formula still, n minus 2 times 180, but now this time we know it's equal to 1,800. So now we can just simplify this and basically solve the equation for n. So we're going to divide both equations by 180. So we get n minus 2 equals 10. And now we can add 2, and we get n equals 12. Okay, so we would call this a dodecagon because that is a 12-sided polygon. And the last example, example number 3, this one hits home for me. I'm a baseball guy, so this is what the home plate looks like on a baseball diamond if you've ever been on one or seen one before. And this is exactly what it is shaped like. It's a pentagon. It's not a regular pentagon though, because not all the sides are congruent and not all the angles are the same. But we do have 3 right angles here. So we have 1, 2, and 3. We know that each of those are 90 degrees. And like I said, we do know it is a pentagon. So we want to find the missing angle measure, or what is the angle measure of these obtuse angles at the corners of home plate. So we know since there's 5 sides, we could say 5 minus 2 times 180, so 3 times 180. And we know that all 5 of these angles should add up to 540 degrees. So now we can write an equation. We know that these right angles are 90 degrees, and there's 3 of them, so 90 plus 90 plus 90, and plus x, and that is equal to 540. And so now we just need to simplify this a little bit. So 90 plus 90 plus 90 would be 270, x plus x is 2x, and that's equal to 540. Okay, so now let's subtract 270 from both sides, and we get 2x equals 270. Divide by 2, and we get x equals 135 degrees. Okay, so that's a little bit about the interior angle measures of polygons.